name is Abdelrahman and today I'll be explaining the equilibrium of a particle. So what are the conditions for the equilibrium of a particle? First, let's start with a particle is at equilibrium if it's at rest or moving at a constant velocity. Newton's first law of motion states that there must be a cause, which is a net external force, for there to be any change in velocity, either a change in magnitude or direction, where it's stated as sigma f equals 0, where sigma f is the vector sum of all the forces acting on the particle. So the best way to represent all of the unknown forces which act on a body is by using a free body diagram. A free body diagram is a sketch showing the particle free, or there is no actual external drawings, from the surroundings with all the forces acting on it. Consider the common connections of this subject as a spring and or cables and pulleys. Looking at the example, as you can see presented, the top picture shows what the problem is asking or showing, and the second is basically showing us the forces that are acting, which makes it more simpler to see or to solve the actual problem. Cables or cords are assumed negligible weight and cannot stretch. Tension always acts in the direction of the cable. Tension force must have a constant magnitude for equilibrium. For any angle, the cable is subjected to a constant tension T. Linear elastic spring. Change in length is directly proportional to the force acting on it. Spring constant or stiffness, which is represented by K, defines the elasticity of the spring. Magnitude of the force when spring is elongated or compressed could be represented using this formula. Force equal Ks, as you can see in the picture, which it makes it easier for us to visualize the formula. Smooth contact. Object rests on a smooth surface. The surface exerts a force on the subject on the object that is normal to the surface at the point of contact. The cylinder is subjected to force T of the cord and it weighs W in addition to the normal force T from the surface, as you can see visually in the example I provided to you. So what is the procedure for drawing a free body diagram? Draw the outline shape, show all the forces, active forces, particle in motion, reactive forces, constraints that prevent the motion, identify each force, known forces with proper magnitude and direction, letters used to represent magnitude and direction. So let's look into our examples. As shown for the hook in figure 1, cable ABC has a length of 5 meters. Determine the position X and the tension developed in ABC required for equilibrium for the 100 kilogram sack. Neglect the size of the pulley at B. So what is the first step? The first step is to find the actual force that is exerted from the sack. So we must multiply 100 by 9.81. So the solution for this problem, as you can see in this next slide. If you take the formula sigma Fy equals 0, we have to take the angle 2t sine the angle, which is unknown, minus 100 multiplied by 9.81, as I said, which then equals 0. So referring to the figure, we can write 3.5 minus x over cosine the angle plus x over cosine theta equal 5. Theta equal the inverse of cosine, because we sent it to the other side, multiplied by 3.5 over 5, which equals 45.57 degrees. This is not the final answer. The final answer is going to be it's going to be brought up by using x multiplied by tan multiplied by 45.57 degrees plus 0.75 equal 3.5 minus x tan 45.57 degrees, which in the end, if we use a calculator, it should bring us x equals 1.38 meters. That's the first part of the answer. Substituting 45.57 degrees into equation 1 yields 687 newtons as the tension. As you can see, the problem is Very simple. The moment you draw the free body diagram, and there's no problem with um, the use of a free body diagram is basically to make it easier to see the forces acting on the object, because a complicated drawing, or as we saw in the question here, it's too complicated. But just the free body diagram, as you can see I provided, makes it so much easier to find the angles, the tension, and where is the force exerted and where's the tension at. Let's take another example, a more complicated one. For the assembly in figure 3, the springs BA and BC each have a stiffness of 500 Newton meter, an unstretched length of 3 meters. Determine the horizontal force F applied to the cord which is attached to the small ring B, so that the displacement of the ring from the wall D equal 1.5. So the displacement has been given to us, it's 1.5 meters. Let's keep that in mind. And each of the strings have a unstretched have a stiffness of 500 Newton meters. So as you can see, the free body diagram drawn, okay? So we want to get sigma Fx equals 0. So let's take all the forces on the x-axis. So it's 1.5 square root, divided by the square root of 11.25 multiplied by x, or the tension, which we don't know, multiplied by 2, because there is two strings, minus F equals 0. T equal Ks, which is the formula I have provided earlier in the presentation, equal 500 Newton meter, or the stiffness, multiplied by the square root under it, uh, 3 squared plus 1.5 squared, uh, close the square root, minus 3. This should equal 177.05 newtons. Put it in the first equation, and this should yield the force, which equals 158 newtons. So that will be all. Thank you very much for watching this video, and I hope it helped you understand the equilibrium of a particle. See you soon.